Hi there guys, we're starting with the eye now, and as usual with the beginning of each chapter, we discuss terminology. So I've got the terminology drawn up here. Remember, if there's anything that in class that we need to add in, we will add in. But what I've decided for this section, because it's so intense, and with this lockdown, we don't want to fall behind either, I've also given you some notes on each part. So I've given you examples: sclera, outermost layer, protects the eye, maintains shape, white in color. So I've tried to give you notes, little notes with the terminology. And let us begin. The eye is protected in the skull by structures known as orbits. The holes in your skull, they are called orbits. We have also lacrimal glands. These are tear glands. They produce a salty solution. And what does this do? It protects your eye against pathogens and dust. It also keeps your eye as a lubricant so that it's not painful when you're blinking your eyes or moving your eyes. You know, you tend to do that when your parents are speaking to you, roll your eyes around and that. And it also has a place for attachment of muscles on the eyes. Look at this. We have the conjunctiva. This is a thin layer around the eye. It protects the eye. Guys, it's this layer when you get infected, you get conjunctivitis, which is known as pink eye. Right? So there's some interesting facts today. And then we have three layers of the eye. We've got an outer layer called the sclera, a middle layer called the choroid, and then the inner one called the retina. And to give you a mnemonic, I think we'll write something here. Remember this, so you remember the order. School, children, run. How's that? Sclera, choroid, and the retina. So if you look at the sclera, it's opaque in color, it's white in color, it doesn't allow for any refraction or reflection. It's firm, it's connective, it fills the entire eyeball up. What it's doing is actually giving you shape of your eye and it's protecting all the contents in your eye. Also, it allows for attachment of muscles for the eye. The second one is called the choroid. This layer is pigmented. The reason why it's pigmented, it's colored, it's because it's absorbing extra light so that you don't have internal reflection like a double vision. It's also, the choroid also has suspensory ligaments. We're going to look at just now what's that, the iris. We're going to look at what's the ciliary muscle, and we're going to look at the function of the iris later. And then the retina, which is your inner layer, has something called photoreceptors. Photoreceptors are cells that are sensitive to light. Let's move on. I'm going to teach all of that to you now. So here's the eye. Alright, and if you look at it, you can see this first white layer, this one here, is called your sclera. So we can actually label it. Let's do that. And you see it's opaque, it's white in color. And it allows for attachments of muscles. It's taking the entire shape of the eye. It's holding the contents of the eye in place. And then in the front of the eye, it forms a transparent membrane called the cornea. So the cornea is transparent. The front of the eye before the lens is called the anterior chamber. And the back, this is called the posterior chamber. How to remember? A comes before P. So anterior in the front and posterior at the back. See how small the areas of the anterior are compared to the posterior chamber. So look at this. We've got the sclera. We've got front of the sclera which becomes transparent. It's not white. That's called the cornea. And then we've got a pupil, which is the space between those two orange parts. Can you see this orange part here and that orange part? That part there is called your iris. We're going to look at in detail. And that space there is called the pupil. So the pupil is not actually a structure. It's just a space between the iris. Okay? And then your middle layer is called the choroid, which you can't see so clearly here. It's a pigmented layer. And this layer here is called your retina. I think the orange one, if you look properly, that orange one there is your choroid. I don't know if I can label it very clearly, but we're going to try. The choroid. The choroid is pigmented. It's the one that's giving you the color of your eyes. Can you see that orange one? And it's made up, in the anterior part, it's made up of this ciliary muscle, ciliary body, and it's got this iris here, and ligaments we're going to look at just now. There you've got your retina, which is the large part, and coming out of the eye is something called the optic nerve. Right? Think of ophthalmologist, optic lenses. Optic means eye. Let us move on. And there's a diagram for you to look at again. There's the, can you see? These ones here, these structures, these white long ones, are called suspensory ligaments. Not nice to label the way we've done, but we call it suspensory ligaments. And think of suspenders. It's something to hold your pants up. You know, you get the straight banners. The one that's holding your pants up, suspend, to hold up. So these suspensory ligaments is holding this lens in place. Look at the spelling of lens. Okay? It's holding the lens in place. And there's a membrane around the lens that's elasticated. So we label that as this elastic membrane. And it's a special adaptation because this allows the lens to change its shape for near and far vision, which we're going to discuss. So we're looking through the first layer, first one, this one here is called your sclera. Right? It's white, it's connective tissue, it's connecting it's got all the muscles attached of the eye together, it's holding the shape of the eye and the contents in place. In the anterior meaning front, it becomes transparent from the cornea. How we do. The front chamber is called the anterior chamber. The back chamber is behind the lens, it's called the posterior. A comes before P, anterior, posterior. Let us move on. And you see here, the anterior chamber has a watery liquid called the aqueous humor. It's very watery. And the posterior chamber has more of a thick jelly-like fluid called the vitreous humor. Let's do this again. We have the lens, the elastic membrane around it. These are called the suspensory ligaments that's holding the lens in place. You've got the iris. The iris is coming out from your second layer, and your second layer is called the choroid. So the choroid is pigmented to prevent internal reflection, gives you the color of your eyes. It's made up of the ciliary body and ciliary muscles. It's got the iris here, can you see? That's coming out from your ciliary body and muscle. The iris has special type of muscles. We're going to look at that just now. And then this space here is called the pupil. It is not a structure. And we've got the cornea in front. You can actually have the conjunctiva like this. Many diagrams show the conjunctiva like this. Let us move on, good people. You're doing so well so far, and I'm proud of you. Let us move on. Here's the diagram again. Now I've taken this one, but I've scratched out labels that you don't have to do. You're doing caps, so you don't have to worry about it. There's our lens. How are we doing? Anterior chamber with aqueous humor, AA. Posterior chamber with vitreous humor. So the two double A's, you start with A first, aqueous humor in the anterior chamber. Posterior chamber with vitreous humor, this is watery, this is jelly-like. How's that? Then we got the iris. Can you see that the iris here, compared to the previous diagram, the iris looked like this. Now we're going more into detail. Here's your iris. The iris is made up of special circular and radial muscles. And that's what it looks like there. If you're looking at it, that's the iris. That part. Let us try and highlight it. Here's your iris. Can you see? That part. Okay? There's your lens. We know anterior chamber, posterior chamber. This part, we can see the sclera. Look at the sclera, how thick it is. Then you got your choroid. And here's your retina. You don't have to know the other labels. There's the optic nerve. Let us move on, and we're going to talk about the retina soon. I'm consolidating the eye with you. Here's another diagram of the eye. By now, you should be a fundi. Here's your ciliary body. Here's your cornea. Aqueous humor, which is in the anterior chamber. Vitreous humor in the posterior chamber. So school kids run. School is the sclera, the first one on the outside. Kids, choroid, run, retina. Retina has photoreceptors. And then we're going to look at something called the fovea just now. We've got the optic nerve, suspensory ligaments holding the lens together, the iris, and here's the pupil here. Can we move on? Are you coping so far? Remember, you can stop the video and go back. Let us look at this now. Now you want to know function. So if you look in the aqueous humor, it allows the eye, look, it's got arrows as a diagram, and we know that it's against regulations to have arrows with labels. But I think what they've done here is to give you an arrow and then the label with the straight line, so you know that that straight line is going with that function of that part. So look at the aqueous humor. It allows the front of the eye from to keep its bulging shape. It separates the cornea from the lens because we don't want it to stick with each other. And then look at you've got this is the lens part. Vitreous humor is here. Here's your pupil, your space. How are we doing? Here's your retina. Here's the optic nerve. The optic nerve goes, it's got nerves that's going to the cerebrum. The reason why it's going to the cerebrum is because it's in the cerebrum that you have sensation taking place. You know that. We have done the cerebrum. So let's take a color. We'll take again. Let's take purple. And let's just say there's the cerebrum. So this is what is happening. This optic nerve is going to the cerebrum where the cerebrum interprets and receives sensation. All right? Now, I want to draw your attention. We've said that the sclera is tough, it's connective tissue. It's in the anterior part, it becomes the cornea. We said the choroid has pigmentation to prevent internal reflection. It also is vascularized, which means that it has lots of blood vessels. So we'll add that on. Choroid is vascularized. So it feeds the eye, feeds oxygen and nutrients. How's that? And I've already put this in your terminology. And nutrients to the eyes. If you go to your first page, you'll see I gave the function there for you. All right, good people. And then we come to the retina. The retina is a special, very special layer. The retina, good people, is made up of photoreceptors. And these photoreceptors, there's two types, rods and cones. So rods, we're going to say rods and cones. Cones, C for cones and C for color vision. This one is going to help you to see bright light and color, while rods is for night vision. How's that? So if you look at the retina, there's a part where the optic nerve is. There is no photoreceptors here. That's called the blind spot. And you've heard of this. Even if you are overtaking in a car, you can't, there's an area that your eyes can't see another car coming out. And therefore, they give you the blind spot mirror to buy. You know what I'm talking about. So here there's no receptors, and simply because that's where the optic nerve is leaving. And then there's an area where there's a high concentration of cones, and that area is called the fovea, or it's called the yellow spot. And it's the yellow spot or fovea where there's a high concentration of only cones, so that your clearest and best vision is formed there. Again, sclera. Can you see? School, children, run. Sclera, choroid, retina. Cornea in front. Your pupil is at space. The iris is showing you the different color of the eye. Here's your lens. And you've got here, you have suspensory ligaments, but the diagram is too dark. Vitreous humor in your posterior chamber. Aqueous humor in your anterior chamber. And there's your optic nerve. How are we doing? Are we good? And here's another diagram. Nice one to learn. Look at the sclera, the white part of your eye. Can you see? And there's your pupil in space, and this is your iris. Your iris is made up of circular muscles, like this, and radial muscles. That's your iris. That gives you the color of your eyes. So even if you buy contact lenses and you want to buy colored contact lenses, you will notice that around that lens, that plastic lens, there's circular and radial muscles which covers up your iris to give you the color of your eye. Let's move on. Again, I'm trying to get this with you, so you're 100%. No errors in your diagram and your label. Please, this is a no-no. Lens, pupil is at space. Can you see this part here? That's called your suspensory ligaments, which is holding the lens together. Suspensory ligaments. Okay? Let's do this again. Retina is photoreceptors, blind spot, optic nerve, iris, pupil, anterior chamber, posterior chamber, cornea. And can you see this part here? This is your conjunctiva. Your conjunctiva. That's where you get pink eye. That's where that gets infected for pink eye, conjunctivitis, right? Alright, so now we're at the retina. We're saying that it's got colors, it's got different receptors, it's massive supply of blood. Fovea is the main focal point with the greatest. Fovea is what is also called as your yellow spot. So this, in your retina, is where your clearest and best vision is going to form. Yellow spot. Well done. I'm so proud of you. Keep focused, guys. We can do this together. Yes. Now this shows you what your rods and cones look like. You're doing caps, so you don't really have to know what they look like. But the layers of the retina include the rod photoreceptors, sensitive to light. Light receptors are called rods and cones. Cones respond to light. C for cones, C for color. How's that? So let's do that. That color, let's choose another color so that you can see this. C for cones, C for color. Right? Rods is for night vision, and we move on. Functioning of the eye. Binocular vision. Binocular vision means you are able to look at an object with both eyes and form a 3D dimension in your cerebrum. It's also known as stereoscopic vision, which we're going to pick up when we do evolution. I've given you a note on this in your terminology and explanation. Formation of the image we're going to discuss. Accommodation, what does this mean? And what does pupillary mechanism mean? We're going to go and do that. We're now looking at binocular vision. What is binocular vision? It refers to the ability of the eye to focus on an object to create a single image. And here's the word stereoscopic image vision. Guys, this is going to link up with evolution. We're going to come to human evolution, and then we're going to know what we're talking about. Right? 3D image means you can see depth, length, breadth, and width. So see how lucky and how advanced humans are. The possible examination question now. You want to know how an image is formed. Please peg this possible examination question. Light is reflected from the object, passes through the cornea. From the cornea, the aqueous humor, which is in the anterior chamber, through the pupil, which is the space, through the lens, through the vitreous humor, which is in the posterior chamber. It falls on the retina where the image is formed. All the structures named above, but pupil bring about refraction. What does refraction mean? It means where light bends. And the point where it meets is called convergence. So if you do chemistry at school, then or physics at school, then you know what I'm talking about. But basically, it's telling you that the light has to bend and bend until it meets directly on the retina, and the best vision is going to be formed on your yellow spot. Structure responsible for refraction, which means bending of light, is the cornea and the lens. Rods pick up the images according to the colors. In this way, light stimulus is converted into nerve impulse on the retina by the photoreceptors. These impulses are converted and carried to the cerebrum or cerebrum for interpretation, which we've done. This is how light bends. You don't have to learn this. It's not for exam purposes. Not for exams, but I've just put it there because I know that you're a smart class of 2020 and you'd want to know. But we can see light bending. If you take a teaspoon and you put it in a glass of water, you can see the teaspoon look like it's bending. That's basically refraction. And because you have the structures, you're so blessed that it allows light to bend and bend until it meets or converges on the retina for complete and total image. What's accommodation? Very easy concept to remember. You know, if you get visitors that come unexpectedly, and sometimes you may get those visitors that come with more than one person unexpectedly, you have to accommodate them. Or perhaps you are studying and then your granny decides to come and visit you. You have to accommodate her. You can't say, no, you can't come, I'm studying, or I'm not in a good mood today, I had a fight with my mother, or your mother can't say she's not in a good mood, or she hasn't cooked enough. You have to accommodate that person. And that's basically what accommodation of the eye is. It refers to the ability of the eye to change its shape so it can accommodate for seeing clear, whether it is near or whether it is far. That's what accommodation is. It's the ability of the lens to change its convexity. The lens is convex. So the more convex is, the better the vision, right? So what is accommodation? Is where the lens is able to change its convexity to accommodate so that it can see near vision or far vision. When we're talking of near vision, we're talking of within 6 meters. And when we're talking of distant vision, good people, we're talking of over 6 meters. Let us move on. And so the story continues. I've got this little diagram just to show you a real eye what it looks like. Can you see? The sclera is white, the iris. If you look properly, you can see the circular and radial muscle. And the space is called your pupil. Please, a pupil is not a learner in your classroom. Then I've taken a few diagrams from the internet just to show you that we're now going to look at accommodation. See, the lens here is long. And can you see that the lens here, when it's long, we say that it is less convex. Less convex. Here, it is fat and round, so it's more convex. And we are looking at accommodation. How is the eye, how is the lens able to change to accommodate for near or far vision? Now, I'm going to teach you this trick, and if you remember it, you're going to be good. You're going to really be all right. Watch this. Because the lens is long here, this is for distant vision. That's how you're going to remember it. For distant vision, the lens will be long-sighted. That means this person can see things in long distance for 6 meters, over 6 meters. And because the lens is short here, this is for short distance, short-sightedness. This person will be able to see things that are closer, within 6 meters. So let's look at it again. See, long, distant vision. Short, short-sightedness, long-sightedness. See here. More convex, less convex. This is for long-sightedness or distant vision, close vision. And that's how you will remember it when you do it. When we really need to push for the finals. Watch this. So already now we know that the lens is less convex, so therefore it's longer. Therefore your trick how to remember this is for long vision, for distant vision, for over 6 meters. This is more convex, it's shorter, it's better, short distance, within 6 meters. How are we doing? Alright. Now for the lens to be long, to be thus less convex, the suspensory ligaments must contract. So we say the suspensory ligaments. Does this make sense to you? I'm trying to teach it to you so you can understand it. The more you understand, the better you're going to do. Suspensory ligaments, we're going to say, they use the word taut. Taut means contract or tighten. Can you see? When the suspensory ligaments tighten, the lens becomes longer. Look at that. And it will make sense because it's the suspensory ligaments that's holding the lens in place. And then when that happens, the ciliary muscles, sorry about my spelling, the ciliary muscles relax. These are antagonistic. Antagonistic means they are opposite to each other. So if the suspensory ligaments are contracting, the ciliary muscles relax. The lens becomes long and thin, or it becomes rather less convex. And this is what your examiner wants. Less convex, its refractive power decreases because it's not so fat. Refractive power decreases and a clear image is formed on the retina. How's that? Now let's look at short-sightedness. See how the light rays are converging? Because they've bent here. They refracted here. Now watch. Ciliary suspensory ligaments. This is for short-sightedness, for near vision. Right? And what happens here? You can see the lens is more convex. For the lens to be so fat, the suspensory ligaments relax or slacken. We use the word suspensory ligaments slacken or relax. Then the ciliary muscle contracts. The lens becomes short and thick, or rather more convex, and the refractive power is increased, light converges onto the retina and a clear image is formed. You have to learn these points. We are on page 112 of your textbook. If you want to refer to it, by all means do so. Here's near vision. When an object is less than 6 meters, and that's everything. Start with the suspensory ligaments. For near vision, that means the lens must be more convex. For that to be more convex, your suspensory ligaments must be slackened. They must not be taut. They must not be tightened. When that happens, then you know your ciliary muscle must contract, and then you can carry on from there. So please, good people, understand the mechanism behind this, and you'll just do well. Now we are going to do something called pupillary mechanism. Pupillary mechanism, this is where the iris changes its muscles. The muscles is making up the iris. So we know that this is the iris. It is made up of circular muscles and radial muscles. In bright light, you don't want too much of light coming to your eyes. It's blinding. Your pupil size will be small. While it's in dim light, you need your pupil size to be larger so more light can go in and more better vision can be found. So they can give you this diagram or this one and ask you. But again, understand, I'm going to teach you a trick how to remember bright light. We will do one bright light. What alphabet comes after B? C. Circular muscles contract. Opposite again, radial muscles relax. How's that? Pupil gets smaller, pupil gets smaller, we can say pupil constricts, and therefore less light enters. See how easy? So don't panic. Look at this one. We're now doing dim light. So the opposite of dim light. Can you see? So we said bright light. In bright light, what's happening? Circular, after B comes C. So now in dim light, you're going to say circular muscles relax, radial muscles contract, pupil dilates, more light enters. And here we've been changing of the lens. It's slightly elastic, just for you to read a little bit. I've got a note on it. The entire thing that I taught to you, remember trick B, after B comes C. So learn it. Bright light, circular muscles contract, radial muscles relax. Let us move on. Okay, let's go on. We're now on controlling light level. Sorry, my apologies. Your eye sensitive, your iris, there's your iris is showing you circular and radial muscles, allows the eye to change the size of the pupil. Again, the pupil is not a structure, it is a gap between the iris. In bright light, dim light now, we finished bright light, now you're in dim light, the opposite of it. Learn one and the other one is good. Here's a adaptation of your eye, good people. And I thought this is a good place to put it in because it's something that you don't really, we've done enough of structure, so I think you don't really have to go home and by heart it. It's easy to learn. The sclera is tough, it's non-elastic, protects the eye. Cornea is transparent for light to pass through. Suspensory ligaments hold the lens in position. How's it? The lens can reflect light. The lens is transparent. The retina has cones and rods. How's that, guys? The cornea is transparent. So these are things, even the ciliary muscles hold the shape of the lens. The suspensory ligaments hold the shape, hold the lens in place. These are things that you don't have to learn, you have to understand. And we've done sufficient of it, which I think you can do. Okay, let's move on now. We are going on to, sorry, I'm trying to put it smaller and I'm doing really bad at it, but let's move on. Nature and treatment of, we've got something called hypermetropia, long-sightedness. Long-sighted means the person can see far-sighted. So I'm going to put this, person can see far, over 6 meters. So let's put this in, and with the red, we'll put that in. Long-sightedness, simply, we're going to say long-sightedness over 6 meters. And how to remember the word hypermetropia? It's a long word. To go to a hypermarket, it's a long way, it's a long distance. So long-sightedness, hyper, long, they can see over 6 meters, right? And then treatment is to wear lenses to see close by images within 6 meters, right? And then we got refractive hyperopia is more commonly referred to as farsightedness. It's the opposite of myopia, which is short-sightedness. This is something you can just read, but you just need to know what are the corrective measures. Myopia, shorter word. See? Short-sightedness. That means in 6 meters. The eyeball is too long, the ability of the lens to become less convex. What do you wear? You have to know, for short-sightedness, you wear a convex lens, and for long-sightedness, you wear a concave lens. That's all. You don't have to learn any of that. Right? You don't have to learn that. And then let's do astigmatism. The front of the cornea is curved in more than one place. So the lens has large focal length and hence less converging power. So this is difficult. Astigmatism is also something they suffer with. The images are distorted. All you need to know is prescription glasses are required with enough eye strain, and you see what happens. They give you glasses, but your eye has to adjust so much because it's going to allow you to look at near and far vision. So many times you suffer with a lot of headache. There's cataract. What is a cataract? You'll see that it's got a cloudy structure over the eye, a cloudy covering over the eye. And it's not understood what causes it, but the treatment is either to surgically remove the lens or they replace the lens with synthetic lens. And now they're doing all of this with laser, guys. They don't really knock you out totally. They just let you lie in the bed, give you a local anesthetic, and they're able to do this with laser, cover your eye with a patch, and within 24 hours remove it, and you're back to normal. So it's quite advanced the medical profession with this. It's a normal lens, and here you can see this is a cataract lens, right? So that's basically it. But to take you a little bit back, I want to tell you, you don't have to learn everything. You have to just know this, that in astigmatism, that the cornea is curved in more than one place, so the images are very blurred. And if you look at it again, it tells you that your image is blurred. Look at your distortion of blurred images. You get headache, right? That's all you have to know. And then if you're looking at previous one, short-sightedness, myopia is a small word, so short-sightedness. You just have to know this is what it looks like. The lens, the rays of light is converging too early before the retina. Can you see that? And you have to have a concave lens. And while it is in my hypermetropia meaning long-sightedness, see, you have to wear convex lens. That's all. And with that, I would like to leave you and love you and say I'm proud of you. Questions will follow onto the WhatsApp group later. Take care, stay safe, and see you soon.